Coating Failures and Defects Overview Part 1. Lecture by Dr.G.Subramanian, Chief Scientist Retired, CSIR Central Electrochemical Research Institute. Coatings are a complex combination of raw materials that must be mixed, applied to a prepared substrate, and dried and cured correctly to perform to their maximum capability. They must be able to be applied in diverse environmental conditions and then be expected to protect the substrate from the damaging effects of rain, sunlight, wind, heat, cold, humidity, and oxygen in various combinations and cycles, and still retain their integrity and often their aesthetic qualities. Some coatings, such as those applied to ships, also must be resistant to abrasion in the case of cargo hold coatings, and cyclic changes of chemicals and tank cleaning in the case of tank linings. Therefore, it is not surprising that these coatings can suffer from premature failure or exhibit defects that may or may not result in failure. It is generally straightforward to establish the reason for the failure of a coating due to the many potential factors that may be involved. These could include formulation, surface preparation, application, drying and curing times, and conditions and environmental exposure, with more than one contributing factor often being involved. Failures and defects can manifest themselves at various times in the life of a coating. Prior to application, they can take the form of settlement and skinning. During application as runs and sags. Shortly after application as solvent popping and orange peel. And during service as blistering and rust spotting. To determine the cause and mechanism of coating failure, all possible contributory factors must be evaluated together. The detailed history from the time of application to the time of failure was first noted. Many coating failures require further evaluation and analysis to be carried out by a qualified chemist or coating specialist, often using specialized laboratory equipment. Most of the following examples of failures and defects, together with descriptions, probable causes, and suggested preventative measures, are outlined in detail in the forthcoming slides. The majority of paint and coating related failures can be attributed to 6 primary causes. These causes are as follows. Improper surface preparation. The substrate surface is not adequately prepared for the coating that is to be applied. This may include cleaning, chemical pretreatment, or surface roughening. Improper coating selection. Either the paint or coating selected is not suitable for the intended service environment, or it is not compatible with substrate surface. Improper application. This can be a problem with either shop applied or field applied coatings, and occurs when the required specifications or parameters for the application are not met. The fourth one is improper drying, curing, and over coating times. Again, this problem relates to a lack of conformance to the required specifications or parameters. The fifth one is lack of protection against water and aqueous systems. This is a particularly serious problem with aqueous systems containing corrosive compounds such as chloride. The sixth one is mechanical damage, which results from improper handling of painted or coated substrate, resulting in a breach in the paint or coating. There are innumerable possible failure modes which can result from these primary causes. The failure modes are divided into 3 general categories as follows. First one is formulation related failures. The second one is substrate related failures. The third one is physical defect-related failures. Before commencing the coating failures and defects, I would like to pinpoint some salient features of this talk. There are nearly 42 types of coating failures and defects. For the convenience sake of the audience, in part 1, I am going to brief about 21 types of coating failures and defects. For initial learners, some of the coating failures and defects would appear to be similar. But when a person becomes a learned professional in this field, he can easily distinguish them. First one is abrasion. The figure on the left top side gives you picturesque view of the abrasion on a coated surface in a ship hull. The mechanical action of rubbing, scraping, scratching, gouging or erosion. Probable causes: removal of a portion of the surface of the coating, or in severe cases, removal to expose the substrate by contact with another object, such as the use of metal chains for lifting, cargo, fenders or grounding of a ship. Prevention: use of abrasion resistant coatings formulated with particular regard to resins and extender pigments. With severe cases of abrasion, the effects will be reduced or limited only by an abrasion resistant coating. The next one is adhesion failure. Figure on the left top side gives you the picturesque view of adhesion failure. The paint fails to adhere to substrate or underlying coats of paint. Probable causes: surface contamination or condensation, incompatibility between the coating systems or exceeding the overcoating time. Prevention: ensure that the surface is clean, dry, free from any contamination, and that the surfaces has been suitably prepared. Use the correct coating specification and follow the advised overcoating times. The next failure defects is alligatoring, otherwise crocodiling. The figure on the left top side gives you picturesque view of this defect. Very large macro crazing or cracking that resembles the skin of an alligator or crocodile. Cracks may penetrate through to the undercoat or down to the substrate. But the probable causes are internal stresses in the coating, where the surface shrinks faster than the body of the paint film. Excessive film thickness and limited paint flexibility. Application of a hard top coat over a more flexible, softer undercoat. Application of top coat before the undercoat has dried. Prevention: use correct coating specification on compatible materials. Avoid excessive film thickness. Avoid application of high ambient temperatures. Avoid application at high ambient temperatures. The next failure and defect is bleeding. The figure on the left top side gives you the picturesque view of the failure. Staining of a paint film by diffusion of a soluble colored substance from the underlying paint to give a undesirable discoloration or staining. Often seen where bituminous or tar-based products are overcoated with top coats in which the tar or bitumen is soluble. Also occurs with emulsion paints. What are the possible causes? Probable causes: bleed through is generally a full or partial redissolving of the previous coat or an ingredient of a previous coat, and can occur when strong solvents are used in the top coats. Prevention: use correct coating specification and materials, use compatible materials, use appropriate sealer coat if possible. The next one is blistering. The figure on the left top side gives you picturesque view of the defect. Dome-shaped projections or blisters in the dry paint film through local loss of adhesion and lifting of the film from the underlying surface. Blisters may contain liquid, vapor, gas or crystals. Probable causes: Many mechanisms can be involved, including osmotic gradients associated with soluble salts, soluble pigments, corrosion products, retained solvents, and solvents from cargoes. Non-osmotic blistering is associated with cathodic disbonding, thermal gradients related to cold wall effects, and compressive stress. Prevention: ensure correct surface preparation and application. Apply a suitable coating system after testing for soluble salts. Consider the possibility of the different blister mechanisms in the particular environment. The next defect is bloom or blush. The figure on the top left side gives you a picturesque view of this defect. A hazy deposit on the surface of the paint film, resembling the bloom on a grape, resulting in a loss of gloss and a dulling of color. Probable causes: paint film exposed to condensation or moisture during curing, especially at low temperature, common phenomenon with amine cured epoxies. Incorrect solvent blend can also contribute to blooming. Prevention: apply and cure coating systems under correct environmental conditions and follow the manufacturer's recommendations. The next defect is bridging. The figure on the top left side gives you a picturesque view of the defect. The covering over the unfilled gaps such as cracks or corners with a film of coating material. This introduces a weakness in the paint film which may crack or flake off. Probable causes: poor application, high viscosity paint system, failure to brush paint into corners and over wells. Prevention: brush apply a stripe coat into corners and wells and fill all cracks and weld them prior to application of the full coating system. The next defect is bubbles or bubbling. Bubbles within a paint film appear as small blisters. These may be intact or broken, leaving a crater. Can be found in excessively thick paint films, especially if spray applied, and also with roller application. This should not be confused with blistering. Probable causes: trapped air, solvent within the coating that is not released before the surface dries, air entrainment during mixing, high ambient temperature during application, also seen when overcoating anti-fouling without removal of the leached layer, and zinc silicates. Can be found with factory applied coatings where application is by dipping, electrodeposition or roller coating. Prevention: in spray application, adjust viscosity with thinners and follow datasheet requirements for maximum application temperature. Use correct mixing equipment to ensure air is not stirred in during mixing. Apply a mist coat. Add defoaming agent to emulsion paints. The next defect is cathodic disbonding, which is described in the left side top of the screen. Blistering and delamination of a coating system around bare steel areas and coating defects associated with cathodic protection on buried pipelines, immersed structures and hulls of ships. Probable causes: high over voltage, principally from impressed current systems, but also to a lesser extent with sacrificial anodes when the number of anodes is excessive. Factors are incorrect installation, poor monitoring and incompatible coating systems. Prevention: use a well-designed cathodic protection system, regularly monitored with well-placed reference electrodes and application of an alkali-resistant coating system. The next defect is chalking. A friable, powdery layer on the surface of a paint film. A change of color or fading is also seen. Chalking rates vary with pigment concentration and choice of binder. Chalking is known characteristics of a certain paints, for example epoxy paints. Probable causes: disintegration of the paint binder on exposure to weathering or ultraviolet light. Prevention: apply a suitable top coat with high resistance to chalking and with ultraviolet resistance. The next defect is checking, which is shown in the figure on the top left side. Find cracks that do not penetrate the top coat of a paint system. Some checking can be so minute that it is impossible to see without magnification. Probable causes: typically a formulation or a specification problem. As with cracking, stresses are developed that cause the surface of the paint film to become brittle and crack. Limited paint flexibility. Prevention: use a correctly formulated coating system. The next one is sizzing. The figure on the left top side gives you picturesque view of this defect. Surface breaks in a wet paint film where the paint has receded to expose the underlying substrate. The paint is unable to wet out the substrate. Can be very large. Probable causes: surface contamination by either moisture or foreign matter such as oil, grease or silicone, also known to happen when incorrect solvent blends have been used. Prevention: ensure surface is clean and free from grease, oil and other contaminants prior to application of coating. The next defect is cobwebbing, which has been described picturesquely on the top left of the slide. The production of the filaments instead of normal atomized particles when some solutions of high molecular weight polymers are sprayed. Traditionally, when applying chlorinated rubber coatings by conventional spray. Probable causes: too high a viscosity with some types of polymer solutions will occur with chlorinated rubber at almost any viscosity. Prevention: reduce the spraying viscosity, select a more suitable solvent blend, change the spraying conditions. The next one is cracking, which has been pictorially depicted on the picture on the top left side. The splitting of a dry paint film through at least one coat to form visible cracks, which may penetrate down to the substrate. Cracking comes in several forms, from minute cracking to severe cracking. Probable causes: cracking is generally a stress-related failure and can be attributed to surface movement, aging, absorption and desorption of moisture, and general lack of flexibility of the coating. The thicker the paint film, the greater the possibility it will crack. Prevention: use correct coating systems, application techniques and dry film thicknesses. Alternatively, use a more flexible coating system. Next one is cratering, which has been depicted pictorially on the slide top left side. The formation of small bowl-shaped depressions in the paint film, not to be confused with the sizzing. Probable causes: trapped air or solvent bubbles that have burst, leaving small craters as the coating dries. The coating has insufficient time to flow into a uniform film. Prevention: improve spray technique, apply a mist coat and avoid air entrainment during mixing. Add thinners as recommended by the paint supplier. The next defect is crazing, which has been pictorially depicted on the top left side. Similar to checking, but the cracks were generally wider and penetrate deeper into the film. Probable causes: application temperature too low, incompatibility with previous coating, aging or high film thickness. Prevention. Apply a thinner coat of paint. Add slower drying solvent. Check the application and drying conditions are correct for the paint system used and check compatibility. Next defect is crow's footing, which has been pictorially depicted on the top left side. The development of small wrinkles in the paint film in a pattern resembling a crow's foot. Probable causes, usually due to the surface drying rapidly to form a skin, which then wrinkles as solvent slowly evaporates from the soft underlying paint. Prevention. Apply a thinner coat of paint. Add slower drying thinners and check that application and drying conditions are correct for the paint system used. The next defect is delamination. It is depicted on the top left side of this slide. Loss of adhesion between coats of paint. Probable causes, provided that compatible paint materials have been used. Delamination defects are generally related to poor surface preparation and application defects such as contamination between coats, exceeding overcoat times, and application to a glossy surface. Prevention. Ensure that no contamination occurs between paint coats. Follow the recommended overcoating intervals. Lightly abrade and clean glossy surfaces between coats. Fading. This defect has been highlighted pictorially on the top left side of the slide. Discoloration or gradual decrease in the color of the paint when exposed to sunlight or weather may be accompanied by a loss of gloss. In some situations, it may resemble chalking but without the powdery surface. Fading tends to accelerate in presence of moisture. Probable causes: incorrect pigmentation, use of non-light stable organic pigments, atmospheric contamination, porous substrate. Prevention: use correct coating systems that resist ultraviolet light and fading. Use a coating with light stable pigments. The next defect is flaking. You have seen pictorially depicted on the top left side of the slide. The form of adhesion failure where paint flakes from the substrate. A familiar sight on wood substrates and on galvanizing. Probable causes: incorrect paint system used, either no or an incorrect pre-treatment used for certain substrates, for example non-ferrous or galvanized. Also, poor application techniques may also be attributed to differential expansion and contraction of the paint and substrate. For example, wood can be the result of aging of the paint system. Prevention: use correct coating system and pre-treatment. Next one is greening. This property has been pictorially highlighted on the top left side of the slide. The underlying surface is visible to the paint film due to inadequate hiding power of the coating material. This is sometimes called greening through, often seen where dark colors are overcoated with the lighter colors. Probable causes: low film thickness of the top coat, poor opacity and covering power of top coat, strong color of primer undercoats. Prevention: apply adequate dry film thickness between individual coats. Use opaque coatings with good opacity. Thank you very much for watching and listening this video.